No, it's Jamal to PRK 19CS1056 and today I'll be explaining experiment number 9 for operating system of the lab on page replacement algorithms. So our aim for this experiment is to write a C++ or Python program to simulate page replacement algorithms, either true of either FIFO, LRU or optimal. So here in this experiment I've chosen to do FIFO and LRU. So this moving on to the description. Page replacement is a basic to demand paging. It completes the separation between logical memory and physical memory. With this mechanism, an enormous virtual memory can be provided for programmers on a smaller physical memory. There are many different page replacement algorithms. Every operating system probably has its own replacement scheme. A FIFO replacement algorithm associates with each page time when that page was brought into memory. When a page must be replaced, the oldest page is chosen. If the recent past is used as an approximation of the near future, then the new page that has not been used for the longest period of time can be replaced. This approach is the least recently used or LRU algorithm. LRU replacement associates for each page the time the page that has been last been used. When a page must be replaced, LRU chooses the page that has not been used for the longest period of time. Least frequently used LFU algorithm requires that the page smallest compound be to be replaced. The reason for this selection is that an actively used page should have a large reference count. Uh, in an operating system that uses paging for memory management, a page replacement algorithm is needed to decide which page needs to be replaced when a new page comes in. A page fault happens when a running program accesses a memory page that is mapped into the virtual address space but not loaded in physical memory. Since actual physical memory is much smaller than virtual memory, small page faults happen. In case of page fault, operating system might have to replace one of the existing pages with the newly needed page. Different page replacement algorithms suggest different ways to decide which page to replace. The target for all algorithms is to reduce the number of page faults. So page hit, if we find the required page in the main memory while the CPU wants to access the page, then it is a page hit. If we do not find the required pages when they're called as page faults, at page faults, we have to look in the secondary memory and fetch the required pages and load into the main memory. So algorithm is as follows. We find the location of the desired page on the disk. We find the free frame. A. If there is a free frame, use it. B. If there is no free frame, use a page replacement algorithm to select the victim frame. C. Write the victim frame to the disk. Change the page and frame tables accordingly. 3. Read the desired page into a newly freed page. Change the page and frame tables. 4. Continue the user process from where the page fault occurred. So moving on to the first method or algorithm I've used, which is FIFO. Yeah. We ask the user to enter the number of frames and reference string. And after that, we use the first in first out algorithm to calculate the page faults and page hits. Here's my output. And then LRU, do the same thing and use the LRU algorithm to get this output. Uh, Thank you for listening to explanation of experiment number 9 for OS Lab.